In the last video, we walked through how to set up a pre-development basin and how we could generate some pre-development discharge rates and volumes. But now we're going to take it one more step and we are going to walk through a very simple site and develop its post-development discharge. We're going to analyze the CN values, we're going to size a pond, and we're going to be fooling around with some iterations of an orifice and a weir. I will say that this still is for a beginner who's just getting into stormwater design. If you want more advanced topics, we will dive into this in later videos. But I'm ready to dive into it, so let's get to it. All right, if you didn't watch the last video, we made a pre-development basin here in HydroCAD. Let me double click that. As I highlight it, you can see the area. So we got 2.5 acres. Let's see if it shows up again. So let's look at how we set up this pre-development area. We called it pre-development. It's about 2.5 acre site. The CN is a 70 and the time of concentration was 20 minutes. But now we are going to be setting up our post-development basin. So what I plan to do is I plan to drag this guy right over here and I'm going to right click. I'm going to edit. And I'm going to call this post-development. It'll be the same amount of acres. However, now we need a new CN. Well, we do have a site plan, so let's actually go to that site plan. I'm going to enter in a CN of 90 for now, just so I can keep this going. We're going to put a pond over here. We're going to right-click that pond. We're going to do edit, and we're going to call it dry pond. So it's really important that you pick your pond type. This is a detention pond. We are going to be storing water. There's going to be a amount of storage here that we're going to set within the pond. But before we do any of this, we actually need to go to our site plan. So here we have a very, very basic site plan. It's a 2.5 acre property here in red. We have an entranceway and a little parking area, a little turnaround area, and a building. You can also see these existing grade contours at 540, 539, 538, 537, 536. So when I'm analyzing a site like this, I notice that all of this stormwater just sheet flows down to the northwest portion of this property. So when I'm thinking about the pond location, I am thinking about the lowest point of the site typically. Now, I'll say that with a caveat because I could totally put a pond over here, but if I end up putting a pond on the higher side, I'm going to be discharging it probably around this parking lot, and it'll ultimately sheet flow all the way down. But the reason why I might not want to set a pond on this higher side is because typically municipalities have certain drainage requirements and drainage codes that you have to follow, where you have to set your edge of pavement grades or your building per the design levels of your pond. So the lower that you can make these values, the less fill that you're going to have to fill in your site. Again, the higher the design values, the higher you have to fill your site. But before we do that, let's start understanding the CN value. So in the pre-development, the CN value here was 70, and you can get this from the TR55 manual. There's a really nice table in that manual that helps you understand the CN values. So all of the other area outside of this building and the pavement is going to be a CN of 70. All of this area within these pavements in the building, that's going to be a CN of 98. So let's start by just understanding what this area is. So let's gather our areas. You can do it a few different ways. I'll show you a nifty way that I like to do this. So you can do a layer isolate in AutoCAD. Let's select that. And I'm going to select these layers right here. And you can do it one of two ways. I like doing some hatches. There's no wrong way. So you can do select objects or pick an internal point. So I'm going to do pick internal point here. I'm going to go there, there, there. And again, there's no right or wrong way to do this. I could also do an area command in AutoCAD. I can also literally just go to the object, go to properties, and get the area there. There's a million ways to skin this cat. I just wanted to get a whole hatch right there. Now, if I get the whole hatch right there, I can go to properties, and it will tell me the area right here. So let's figure out what that is. Keep in mind, this is in square feet, so I'm going to go, if you didn't see what I just did there, I'm going to go to this area calculator there. Click that little calculator button, and I'm going to divide this by 43560. Sorry for all of my metric people out there. I work in the United States, and unfortunately, we use this Soul here English system. So let me press enter. So we have about 0.681. I like to go to 3 sig figs there. So I'm going to say 0.681. And that's important because that's how much impervious area that we have. Impervious area, guys, means that water, when it hits any of these areas, it's not permeating into the ground. And this directly affects our CN value. Now, in order to just go all the way back, you can do Control Z. I'm just gonna do that. So let's go back to our HydroCAD and let's go back to this basin because we're really not done with this basin yet. How I'll split this up is, even though we have 2.5 acres, what you can technically do is you can do this. I'm gonna go ahead and enter in my impervious area. And what it'll do is it'll create a composite CN. And I'm going to leave this as 70. I'm going to subtract the 0.681 acres from the 2.5 acres. So what would that end up being? Do I really need a calculator for that? Sure. My brain's kind of slow today. Now it can create a weighted CN. Now, one thing I'd like to point out here, guys, is we went from a CN value of 70 to 76 with our post development. So what that means is that there's going to be a little bit more runoff generated. The higher that this CN value gets, the less the water soaks into the ground. We're going to have more surface runoff. That's a very important concept. So when you start thinking about these things, it's so important that if your CN were to go from like a 70 to a 90, that's a really big swing. So you're probably going to need a lot of pond. So once you do more of this, you'll start to make those connections. So now we'll fill out the TC. And guys, you can definitely create your own time of concentration calculation. A lot of municipalities will just tell you to use a minimum, which a lot of the minimums, it really depends on the project. Sometimes it can be a minimum of 10 minutes, a minimum of 20 minutes. So with this, I'm not going to walk through the time of concentration path. We are just going to use the county's minimum, which is 10 minutes. I do have other videos that shows how we can calculate a TOC path. You know, for this example, it's not going to throw it off too much. So I'm going to do just a standard direct entry. And I'm going to say 10 minutes. I really just want to show you guys how to size this detention pond. So we're cooking with fire. Looks like our weighted CN actually, okay, it just updated. At first it said 76, but now it's 78. Interesting. Okay, we're gonna hit apply. Now we gotta figure out this dry pond. So we're gonna make sure that we can actually route this basin to this pond. So what you can do is do right click, you can do reroute, and we need to select this node number. And this node number is that dry pond right there, 3P. You can barely see it, but we got to make sure that we select that pond. That means that this basin goes into that pond. But what about this pond, guys? We need to size it. So kind of what we do in drainage, you know, you can get really technical and you can be really smart and do a whole bunch of fancy equations. But a lot of times early on when you're doing these test fits and these site planning efforts, a lot of times it's iteration based. A lot of times we already have a general pond size and we go from there. I mean, a general rule of thumb is you want 20% of the site to be pond or some sort of storage. Let's start understanding our pond. I know I want the pond here in this general location. So let me zoom in. You can do a zoom window. Really like that feature. And I'm just going to start drawing a pond. Always look for your county's regulations. A lot of times there are setbacks and buffers, but this is just such a simple site, guys. We're not going to be digging through all of the different code. Pretty standard here. I'm just going to do some of this. What'll be fun about this is we can see, you know, if my guesstimate was even any good. So I want to create some separation here from the building. You know, we might end up changing the site plan and route the sidewalk around the building. That could be a thing. So honestly, I'm going to give myself like 25 feet. Let's do that. And this will be the place where I am setting my top of bank. I usually start with a top of bank area and then do my offsets inward to generate the pond shape. I'm going to create some setbacks here. I'm going to do 20 feet just for grading, and then I'm going to do 20 feet here. Let's see what else we got. I'll do a polyline. I'll go perpendicular. Always make sure you're going perpendicular. Keep your lines clean. Let me show you a few little nifty tricks if you're not an AutoCAD user. I like to use the fillet. Some people call it fillet. Pretty sure it's fillet. I like to do fillet radius, 10 to 30 for a fillet radius, and I can just show you really quick what the difference is. So right now I'm using a radius of 30. So watch what happens when I select those lines. See, 30 is pretty pretty large. I'm going to slim it down to like 15. Yeah, that's a little bit better. So I'm going to do that all around these points right here. Another AutoCAD tip is you can just press the space bar and that'll your very last command. So that's nifty. So here we have a little pond. So this will be, the top of bank of the pond. And what I plan to do is I plan to just go from here and inward. So usually when you're grading ponds, you never really want to go any more than 4:1. You can definitely have a 3:1 pond. And again, 4:1 means grading 25%. 3:1 is grading 33%. So 3:1 is steeper than 4:1. And the reason why you don't really want to go 3:1 is because it is a hazard. People can fall in, trip in this pond. Some codes will require you to build a fence if you do have a 3:1 pond. So I'm going to stick with 4:1. Now, what does 4:1 mean? 4:1 means we're going to drop 1 foot for every 4 feet. So if I'm going to drop 1 foot for every 4 feet, if I do an offset of 4 feet, that represents a foot of drop. I'll show you how this makes sense here. So let's offset. Let's go 4 feet. I'm also going to explain a few things after this about, our depth of the pond and, how deep we can actually go here. So guys, again, this right here is my top of bank and this will be my bottom for now. But let's start understanding our code and requirements. So I've pulled up a little bit of code in our geotech report. This is so important. I'm never just doing this as a design and just throwing lines in here. A couple of the things I like to read is the geotech report. The geotech report will tell you the seasonal high water of the site. And for this site, the seasonal high water is actually at elevation 530, meaning in this location, if we were to cut all of this existing grade down, we would strike water at 5:30 during a seasonal, rainy time period. So since that is the case, as the designer of this property and us talking to the owner of this property, they really don't want a wet pond unless we have to. This would become a wet pond if we were to dig down to the elevation of 530. We're going to keep this as a dry pond. So in that case, what we could do is we could go as deep as 531. It's usually a standard rule of thumb to set your bottom of your dry pond 1 to 2 feet above the seasonal high water. So if that's the case, my bottom can be 531 or 532. Maybe let's just start with 532 and go from there. So if my bottom of pond right here was 532 and I had 1, 2, 3, 4 contours, well, that's 1, 2, 3, 4 feet that I'm going up in elevation. So if my bottom was 532, that would make my top of bank 536. Now, does this actually make any sense? Well, if I made my top of bank 536, that means that I'm digging into the ground for my top of bank right here because this is an elevation of 538. So if I were to make this contour 536, well, I'm digging in all of the earth right here. So you know what? I'm actually going to go backwards around here. And since all of this elevation's 538, I'm just going to match existing grade. So I'll show you what I mean by that. I'm going to make this contour right here 538. So if I'm going 4 feet down, 1, 2, 3, 4, that means that that bottom there is 534. And the good part about that is, I'm cutting the earth. That's the whole point of the pond, is to generate some cut here. The reason why I kept this at 538 is just because I want to just hold some existing grade there. There's nothing wrong with that. There was also nothing wrong with holding the 536. But it just would have made a cut condition there. Also, 538 is fine because what it does is we can help berm up this area and grade back down to the existing grade. Because if this is at 538, I need to grade back down to 536. So I'm 2 feet higher in the air. And I can grade that back slope of the pond down to existing grade. Kind of create a buffer if any backwater or tailwater were to ever come into this property. Maybe we're in a floodplain. And there's some floodplain on our site and we're, not trying to backwater any of that floodplain into our pond, that could be a case. Every site's different. These are just the things that I'm thinking about. Well, since this is the case, this is our first go with this pond. So let's go back to HydroCAD. Let's go back to this dry pond and give it a volume. So let's right click it, Let's do detention pond. Now let's give it some storage. Let's go to the storage tab. Let's double click. So what I like to do for these ponds is I like to give it just some custom stage data. That way I can actually give it an elevation and a surface area because the program will automatically calculate the volume. I usually like to start at my lowest point. So I'm going to do the 534 and then we had the 538, but we're going to need those areas. We're going to need the acreage of those stages. So let's go back. Let's get the area of that elevation 534, which is roughly 0.11. I'm going to round here, 0.117. Okay, now what's 538? 0.243. All right, let's enter those in. So with stage type, I just like to keep it as surface area. This will automatically give you a cumulative volume. Now the next thing that we'll do is we'll set up an outlet, but I just want to run the program and just see how high the storage node fills up before we start putting any outlet structures. So now since we have this model set up, all you have to do to run it is just double click this pond. So this was actually perfect. So we've received an error. Pond 3P unable to extend routing tables above 538. What that means is that this pond is simply not big enough to store all of the water without bleeding some of it out. But this happens to be a project where we're not required to retain all of the stormwater. What we are required to do is meet the pre versus post discharge rate. So always read your municipality's code. For this code requirement, all we have to do is meet the 25-year pre versus post. It's really, really important, and I hope everyone pays attention with this. Let's right click this pond. When you are doing outlet structures, you have to go in order of the most downstream component to the most upstream. If we were to make a structure, like a drop structure in this case, which is a control structure, we can add an orifice, a weir, a pipe. You always want to go from the pipe to the box. So in this case, we would do pipe first, weir, and then the orifice. Also, there's a lot of really good help in here. If you're ever just really unsure, they have really good help stuff in here. So let's first enter in the culvert that we need since we're going to have a drop structure, which is a box to a culvert. So let's do culvert first. This will be primary routing, but we'll get to that in a minute. We're going to set that inlet invert to the bottom of the pond, and we're going to have to draw some cross sections on all this stuff. But, just to get some of this design moving, let's go ahead and set the invert to what the bottom of the pond would be. Outlet invert will be 533 with a length. I think it was around 41 in our plan for now. Let's see, Manning's number. Let's assume that this is RCP. So this will be 0.013. And then let's go over here to diameter and let's do 24 inches. Also, another thing about designing, because, some of the experienced people, if you guys are watching this, you're probably wondering, well, how are you going to have an outlet invert at 533 when your grades are 534? Technically, that water won't pop off until the 534 or 536. Let me see. Yeah, our existing grade's 536, so that pipe's going to be underground. Well, yes, you are totally right. And in probably this case, I would either have a bubble up structure, or perhaps what we could do is have the culvert within the pond and then have the control structure on the outside. There's a lot of different ways to think about this concept, but I want to save all that for more of the advanced topic, because control elevations, tailwater, those are all very, very important in the design. For now, I really just want to assume a free outflow. I want us to understand just the very basic concepts of volume and how orifices and weirs can control the discharge rate of water. But I already know where all you advanced guys are thinking. So trying to beat y'all before you put the comments in. So all this is assuming free flow. So we put in our culvert. All right, we're going to put 0.5 for KE. You could probably look up some other factors. Now we're not done. We're going to have to keep entering in more information, and we're going to tie in the orifice and the weir to this culvert. So let's go to, I think I'm actually just going to do an orifice first. So in order to do an orifice, you can go down to here, orifice, great. And we are going to route this to device 1. The Orifice grate will be routed to the pre-existing device 1. This will cause the flow to be governed by the device with the lower capacity at each head. If this device discharges from the pond independently, set the routing primary or secondary. The reason why this is so important, guys, is because if I had both of these at primary, that means that water would be discharging out of both of them at the same time, and that's not technically the case. I want the orifice to be the main controlling point of this pond. Now, since that's the case, that is why I chose the routing to device 1. Very important. We are going to set that orifice to the invert elevation of 534. So we're going to set it to the very bottom of the pond. So we are going to enter, let's actually start with a 4-inch diameter orifice. Let's do that. You can enter an amount of rows. We just got 1 row. We don't have to enter in a width or a height. We can just enter in the diameter. Vertical plane. So the opening is in a vertical plane. That means that the cross section's vertical. So when I build this box, water is going to be flowing through the box, in a vertical plane, not horizontal. Horizontal would be like a grate or like a siphon, but we're not doing anything like that. So I'm ready to press OK. And now we have our routing. In this case, there is no tailwater. We're going to have free discharge. Always just be very careful about what you do because tailwater is so important. Once we do a little bit more videos and we get to more advanced subjects with stormwater modeling, I'll introduce tailwater. But let's press OK. I'm ready to run this storm. Let's double click this pond. All right, we got some more errors. However, we're finally now able to see what's going on. So it looks like our storage is exceeding. Let's blow this up here. We have an inflow of 10.42 CFS. And this pond is only outflowing 3.84 CFS. Let's go to events. Here's what I'm seeing, guys. It's great. We are meeting the post-development discharge rate, at least I think we are. Let's actually double check that. So our pond has to release less than 8.14 CFS because that's the pre-development. We can't release any more than that. So right now, our pond is releasing, if we go to events, it's releasing 3.84, but this design is not done. Look at the elevation. It's 615. 615. Our pond bank is at elevation 538. We're completely flooding this property. This pond is not sized accordingly, or we can release more water out. And this is the golden thing of what I've been trying to get to this whole time leading up to this video is sometimes stormwater design is an iteration game. Sometimes you will either have to play with the volume, sometimes you will have to play with the weir configuration, the size of the weir. This is actually when it becomes fun. The first step is just getting to this level of actually having some sort of design to work with. So I think what we should do, this is a very high elevation. We can open up the orifice. So let's just try that. Let's go to outlets, orifice. Shoot, I mean, let's do 6 inches. If that's not enough, I mean, we're just gonna have to put a weir in it and call it a day. Let's go. Okay, looks like we're getting somewhere. There we go. Interesting. All right, elevation 537.44. So I'm gonna do a couple more iterations, and if that's not the case, then we're gonna have to give this pond a little bit more volume. I'm gonna keep that at 4 inches. But I'm going to put a weir. So I'm going to double click right into here and we're going to add a sharp crested rectangular weir. This is very common in control structure boxes. So we're going to set that at 535. I like nice round numbers. It's also higher than the orifice hole. So that's a plus. Let's do a crest length of 3 feet. Let's really open this up. So the crest height's optional. We don't really need it. I'm just worried about the crest length in the rise. So this is really important. I mean, if I'm going to have a box in this pond, the highest I could go is up to that top of bank. So I could either enter in the top of bank, which is 538, or I can just enter 99999 because these stormwater models are just going to solve, to an infinity. It's going to give me my stage whenever it processes the whole hydrograph of the storm, if that makes sense. So we're going to be solving for the stage. But if that's confusing for everyone, let me just use 538. Forgot, we got to route it to device 1. Let's do apply. Let's press OK. Let's double click and let's see what happens. All right, we're might be getting somewhere. And this is funny because I wasn't doing any background on this. I literally whipped up this site plan. It was very random. And then our elevation for this 25 years, 535. I mean, let's call it 536, 534, 538. Okay. Let's double check our pre-development discharge. Okay, yeah, we're not meeting our discharge by like barely any though. 8.14, we gotta meet it. What was this again? 8.17. All right, let's go back to our pond. Let's do outlets. Let's hold back our weir, okay? Right now we have it at 3 feet. Let's dial it back to 2 feet and let's see what happens. All right, that's probably more like it. Well, we have a primary CFS of 8.03. That's the checkbox of meeting the pre-development rate. And then this pond is staging up to an elevation of 535.95. Let's just round it to 536. So we have a buffer of 2 feet between this design high water and our top of bank. So just to put that into perspective here, our design high water is staging up to this contour right there, which is pretty good. Considering that's the case, technically this pond is a bit oversized here. So I could either, not dig so deep. I could decrease the size. I could lower the top of bank. I mean, there's so many things that we could do. And that's the beauty of stormwater is, you have a million decisions, but as long as you know the key factors, which is sizing your weir and then sizing the volume of the pond. Everything after that can just get really creative. I've seen a lot of projects use underground chambers when space is limited. There's a million ways to skin this cat. But that's honestly all I have for today, guys. I was trying to make this rather quick, but this ended up being a really in-depth video. I hope you guys learned something new. If you are a beginner in this industry, comment below. I'm really excited to grow this community, learn more about stormwater, grading, and everything there is to know about land development. If you have any questions, feel free to comment below, and I will see you in the next video. Peace out.